Pythagorean theorem is used for any right triangles. So in this given, we can see that it is a right triangle. So we can apply and use the Pythagorean theorem. So it says that the hypotenuse is equal to the sum of the squares of the short and long leg. Let's first identify the parts of this triangle. Let's say A is our short leg, B is our longer leg, while C is our hypotenuse. Okay, this is our short leg, our longer leg is B, and this is our C. And the Pythagorean theorem states the hypotenuse is equal to the sum of the squares of the shorter and longer leg. So that's how we write it. So let us substitute. The value of our C is missing, so let's just write C squared is equal to the value of our A, which is 3 squared, plus the value of our B, which is 4 squared. Then simplify. C squared is equal to 3 squared, 9, plus 4 squared, 16. 9 plus 16 is equal to 25. C squared. So to solve for this, we need to use squaring of both sides. So that C is now is equal to the square root of 25. So the square root of 25 is positive and negative 5. But since this is a length, there is no negative length. So let's just take the positive side, or positive number. So C is equal to 5. In this case, our hypotenuse is equal to 5 centimeters. This given, again we write the values of our parts. So we have the A, shorter leg, is 4. The B, which is the longer leg, is X. And the C, which is our hypotenuse, opposite the right angle, is 8 centimeters. Now, to solve for this, the Pythagorean theorem, C squared is equal to A squared plus B squared. And then we substitute. C squared is 8 squared is equal to A is 4 squared plus B squared. Simplify. 8 squared is 64 is equal to 4 squared is 16 plus B squared. Then we apply addition property of equality, or the inverse, add an inverse of this, negative 16 on both sides. So the answer is B squared is equal to 58. Then we square both sides. B is equal to factors of 48 with a perfect square. We have 16 times 3. Square root of 16 is 4 times the square root of 3, which is equal to B. This is now our answer to the question, what is our longer leg? So we have here 4 square root of 3 centimeter for our X. For next given, we have, what kind of triangle is this? Yes, this is an isosceles triangle because the legs of the triangle are congruent. A is 5, our B is 5, and the missing is our hypotenuse, which is missing. Pythagorean theorem. c squared is equal to a squared plus b squared. A squared is equal to 5 plus b squared to c squared. So this is 25 plus 25 is equal to 50. C squared, square root. So we factor 50, we have the square root of 25 times 2. So C is equal to the square root of 25 is 5 square root of 2. So this is the answer to our hypotenuse. We can also apply special triangle theorem, which is a 45, 45, 90 degrees triangle. In a special triangle, let us remember that we just multiply the leg and the square root of 2. So, and that would mean the leg is equal to 5 and then times the square root of 2. So you see, we still have the same answer. For our problem, let's have this given. A ladder 13-meter long is placed on the ground in such a way that it touches the top of a vertical wall 12-meter high. Find the distance of the foot of the ladder from the bottom of the wall. So let us first sketch the problem. Vertical wall, perpendicular to the ground. Okay, so this is the ladder, 13-meter long. And the wall is 12-meter high. Okay, so the question is this point to the bottom of the wall, which is this point. So this is what we are looking for. We have A is equal to X, B is equal to 12, and the hypotenuse opposite the right angle is C, 13 meters. So applying Pythagorean Theorem, c squared is equal to a squared plus b squared. C squared is equal to 13 squared, and a is missing. So let's just a squared plus b squared is 12 squared. So 13 squared is 169 is equal to a squared plus 12 squared is 144. Applying addition property of equality, we subtract 144 on both sides of the equation. So that would be a squared. So square root, square both sides. So a is equal to 5. It answers the question, the distance between the foot of the ladder and the bottom of the wall. So the answer here is 5